here at the Consumer Electronics Show in Vegas 2022, showing off the RAD-IO2 product and the ValueCAN Industrial. Working from the left here, we're controlling with a hand tilt pad, this little dice thrower that I made. There's basically two half bridges using the digital output, and we're controlling that with a PWM. In addition to that, the digital output's controlling this actuator here as a full bridge output. We're also measuring a thermocouple. You can see as I touch the thermocouple goes up there. And in addition to that, we're measuring the voltage and current, and you can see the graph of the current from the actuator. This whole system here, as you can see from the diagram, is fed into the RAD-IO2 port of the Industrial ValueCAN. So the Industrial ValueCAN has a RAD-IO2 port. It has a HSCAN1, has HSCAN2. Not shown is a LIN port. In addition to that, to connect to the PC, you can do it through either USB or Ethernet. We're using USB in this case. In addition to that, we've integrated the VividCAN into the HSCAN2 port of the Industrial ValueCAN. And right now I have the auto dice mode on. You can see I just turned the dice mode off, and you'll see from there, if you want to point up there, I'm going to individually throw the dice and individually throw it back. And I'm going to put the auto mode back on. So we have the ValueCAN, and you can see the numbers moving on the VividCAN. So we have two-way communication going to the VividCAN from the Industrial ValueCAN. On the other side here, we have a analog output, and you can see the LED lights up. We have a relay board here. You can see I'm flickering the relays back and forth. And we have an analog input connected to a solar cell, and you can see the voltage on the solar cell change as my hand goes on it and off of it. Now, what's important about this, to show about this, is that this is all connected to the device through the CAN hub. The CAN hub turns the UART, the native UART or USB signal from the RAD-IO2 directly into a CAN signal, so you can use it with a ValueCAN, or you can use it with anybody's CAN devices. So even if you have CAN devices from competitors, you can use our RAD-IO2. Basically, a breakdown of the modules. Again, the DIO is eight banks, 4 banks of digital input, 3 inputs each, so that's 12. And there's 4 banks of output, and then each bank has a half bridge, 2 half bridges, which can be used as a full bridge. This is K-type thermocouples, and these are analog inputs. The important thing about the RAD-IO2 is everything is galvanically isolated to at least 1500 volts. So you don't have any issues with common mode or shorting between channels. And as far as the relay section here, the analog outputs go, there's 8 banks of analog output. Each bank has 3 analog outputs, 0 to 5 volts. You can cascade these and actually generate 40 volts out of this, and then you could cascade further modules to actually to almost anything you want, up to 1500 volts. That would be a very easy way to do battery cell simulation. In addition to that, on the relays here, these are high quality telecom relays capable of 5 amps at 250 volts AC or 220 volts DC. And on the analog input, we have there's 2 analog inputs per bank. You can only use one at a time. The lowest range is -5 to 5 volts, which actually the lowest range of that is 250 millivolts plus minus. And on the other pins, we can do up to plus or minus 45 volts. So that pretty much concludes the system, and the whole thing is of course programmed through vSpy and through function block programming. You got your graphical panels, you got your messages that are coming through, either your HSCAN, neoVI, HSCAN2.